My data capstone project is on traffic accident analysis. The Department of Transportation's National Highway Safety and Traffic Administration collects traffic accident data on vehicles, roads, and human characteristics to improve road safety. Aggressive driving is a high risk factor. It is more common with increased travel and congestion. Behavior includes running lights, not stopping for stop signs, driving too close, speeding, unsafe lane changes, and weaving in traffic. In 2019, there were 36,096 fatalities, but that number increased in 2020 by 7%. Vehicle miles traveled decreased in 2020 by 13.2%. The cost of traffic fatalities is $150 billion annually, and it costs taxpayers 13% of the ER cost and 26% of hospitalization. Collision risk factors include distracted driving, driving under the influence, failure to wear a seatbelt, high rates of speed, driving too close, aggressive driving, and traffic congestion. These numbers can improve with vehicle safety options. Crash detection. With cameras in the front and rear of a car, the crash can alert the driver if a crash is imminent. Automatic braking can further that by stopping if the person does not brake in time. Blind spot monitoring cameras are also helpful so that incorrect lane changes don't cause an accident. Some cars are equipped with vehicle safety communications so that if there is an accident, emergency personnel is called right away. Other features like automatic headlights and automatic windshield wipers are additional safety features that are optional. Roads can be designed to reduce traffic congestion and to allow for pedestrians and bicyclists. Protected left turn phases can be implemented. Pedestrian crosswalk countdowns can be added to busy streets. Traffic calming devices include speed humps, traffic limit signs, and roundabouts have proven to reduce traffic accidents. The future trends indicate the population is growing and the population age is changing. More younger people are on the roads, and as the population lives longer, there are older people that are still driving on the roads. Ethnic mix could play a part due to immigration, which means traffic safety features need to be communicated in multiple languages to help increase safety so that everyone understands how to drive safer. The population distribution also indicates a change as people move from cities further out into the suburbs and have to use highways and drive at higher rates of speed and traffic congestion to get to work. Economics and travel patterns also have an effect on the amount of traffic congestion. As the economy improves, people are traveling more, going on more vacations, and that creates more traffic congestion. The National Highway Transportation and Safety Administration has a nationwide reporting system called FARS, or Fatality Analysis Reporting System, which collects data on fatal crashes and reports this to Congress and the American public. The crashes included are located on public roads where a person involved in the accident died within 30 days. The data is compiled into fact sheets and tables on the website, or it can be downloaded using a built-in online query tool. The map shown indicates that traffic fatalities between 2019 and 2020 are increasing. And on the East Coast, it's increasing by about 9%, which is Region 3. Vision Zero is something that was started in Sweden in 1997 to improve road fatalities and injuries. Swedish were able to reduce the number of road fatalities by 50%. Vision Zero's goal is that there are no fatalities or serious injuries due to road accidents. It is not acceptable for human mistakes to have fatal consequences. Previously, the thought process was the responsibility of road safety was on the road user. but that thought process has shifted to that of road engineers, researchers, and policymakers to make the roads safer. It is everyone's responsibility. Over 1 million lives each year are lost due to car accidents. The Safe Roads policy was implemented in about 53 countries. They have a goal of 0 road deaths by 2030. And if something's not done, there will be 1.25 million lives lost each year worldwide. The global leading cause of death is young people between the ages of 15 and 29. Multiple strategies have been suggested which will help reduce this number and achieve that goal. That includes safe driving education, such as through television advertisements and billboards, about watching out for bikes and pedestrians, driving slower, not using your phone while you're driving, designing roads to reduce traffic congestion, adding pedestrian walkways, adding more vehicle safety features, such as crash detection warnings, and to analyze traffic data to reduce accidents and accident severity. The U.S. Department of Transportation has adopted the goal of 0 road deaths. Humans are fragile, and they do make mistakes. Making the roads safer is a shared responsibility, and it should be proactive by implementing safety features in the transportation system, then reevaluating accidents using crash data. Post-crash care, such as ambulance response rate, is also a key factor in saving lives. The start of a data science project involves understanding the business area related to the problem. For this project, I read published traffic accident reports and read about safety measures and statistics to better understand the problem and the transportation industry's goal of 0 deaths. From there, I downloaded a data set and explored the features, looking for duplicate values, missing values, and outliers using both SQL Server and R. After data wrangling is done and exploration is done, feature engineering is a tool that's used to reduce dimensionality and to identify features which will help the model achieve a higher accuracy. The models are then developed and the final report is prepared. SAS Enterprise Miner is a great tool to learn about a data set and develop many models quickly. SAS defined the data mining term SEMA, which refers to sample, explore, modify, model, assess, to uncover unknown patterns in large amounts of data. The process involves taking a small sample of the data set, explore to find relationships, trends, and anomalies, modify the data to assist in model selection, develop the models, and then use the model scoring feature to assess accuracy. I will be using SAS Enterprise Miner to create the models for this project. Other research projects include a study done using UK data for road traffic accidents between 2005 and 2019. It was done by researchers at Al-Qura University. The goal was to develop a model that could be used by other data sets from other countries to predict accident severity and identify contributing factors. Over 90% of world road fatalities occur in low to middle income countries. The financial loss felt by those countries often exceeds what they receive in developmental assistance. The World Health Organization estimates that if something isn't done, 2.4 million people will die each year from car crashes, and it will become the 5th leading cause of death by 2030. The research team found of the models produced, XGBoost and random forest outperformed other models such as neural networks and logistic regression, with an accuracy of about 74%. More than half the accidents they found occurred with lower speeds of no more than 30 miles per hour. Another research project I studied included road accident prediction hybrid. They used the hybrid k-means and random forest models with a data set of 5,000 accidents from 2011 to 2018 in Ethiopia. The study was published in August of 2020 in the SN Applied Sciences Journal. The researchers achieved an accuracy of 99.86% with their hybrid model. They identified contributing factors such as the type of injury, whether it be serious or fatal, how much experience the driver had in driving the car, whether it was daylight or night, and the service year of the vehicle. The NHTSA analyzed traffic data both before and during COVID-19. During 2020, about 19% of the people stayed home nationwide due to the lockdown order. This meant fewer vehicles were on the road, yet higher speeds were reported and ejection rates were much higher, meaning they weren't using seatbelts. It was also reported that more accidents were the result of driving while intoxicated, and that corresponds to the graph in the Census Bureau below, showing an increase in alcohol sales during 2020 and 2021. Expected results and conclusions. I expect to deploy a model to predict accident severity with at least 80% accuracy. I further expect to identify features that are correlated with higher severity. I would expect to see fewer accidents in 2020 since many people were on lockdown due to COVID-19, but I also expect a higher severity rate. I feel that it will show regions with higher income and employment numbers will have more accidents, and that more accidents will occur on highways versus lower speed roads. Key performance indicators include identifying the key factors involved in more serious crashes, such as were the accidents near bars and restaurants? Did they occur at stop signs or traffic lights? I also expect to identify if weather was a factor in more severe accidents. A key performance indicator of the model would be 80% accuracy. I hope to achieve this using dimensionality reduction and feature selection with logistic regression model and principal component analysis. SAS Enterprise Miner is the tool I will use with the scoring feature to use precision, specificity, accuracy, and recall to identify the most accurate model. A third key performance indicator would be to identify crash location. Do more accidents occur on the local road or on high-speed highways? Is population a factor? So areas that are more heavily populated have more people driving on the roads to go to work. Finally, reducing fatalities is a fourth key performance indicator. The goal is to reduce fatalities in 50% by 10 years and to have zero traffic deaths by 2030. The data I'm using in my project includes the U.S. accident traffic data from Kaggle.com, the Census Bureau income data for the period 2016 through 2020, Bureau of Economic Analysis employment and population data, COVID-19 data from healthdata.gov. These will be combined to be called the Northeastern Traffic Data Set. The U.S. accidents data set contains 1.5 million records with 47 features. Accident data from 2016 through 2020 was collected using APIs from MapQuest and Microsoft Bing. These included longitude and latitude, start date and time, the distance of the road that was affected by the accident, including the address, city, county, state. The data set was accentuated by the researchers using Weather Underground to create features such as weather code timestamp for the time of the accident, the airport code to know where the nearest weather station is near the accident. They added wind speed, humidity, pressure, precipitation levels, and weather condition. The data was also accentuated with OpenStreetMap, which identifies by longitude and latitude any points of interest on the roadway of the accident. So this would include stop signs, traffic lights, libraries, railroad crossings, roundabouts. Finally, time and date was added by the researchers so that they could pull in whether the time of day was sunset or sunrise, or whether it was twilight. I found the data had some duplicate records due to inconsistent collection of weather data. So the data set was also very large, so I am only including the Northeast region, which stretches from Virginia to Maine. I added time of day feature, which indicates whether it's morning, afternoon, evening, or nighttime. The target variable is severity, indicating the severity level of the accident. The weather feature also had some duplication, so I created two new fields, weather type and severity. Weather type indicates whether it's a clear day, raining, or heavy storm, and that's rated with a severity of 1, 2, or 3, 1 being not very severe. I also created a feature called road type to identify whether the traffic accident occurred on a local road or on a high-speed highway.
The census data on population was obtained from the Census Bureau, and the income and employment data was obtained from the Bureau of Economic Analysis for the period of 2016 through 2020. The employment data shows the number of people employed by state, county, and year. The income data contains the total income by state, county, and year. The population data from the Census Bureau shows the population breakdown by state, county, age, and gender.
The COVID-19 data is collected on an individual submission day and by state. It will include total cases and total deaths. That is to compare the number of accidents before COVID and then during the COVID lockdown. So this is a view of the entire data set. The census data is in purple. That includes population, employment, and personal income that will all connect to accidents by both state and by year. And COVID data will be connected by state and by submission date. The final data set is called the Northeastern Traffic Data Set. It contains 229,871 observations with 36 features. Thank you.